Let's discuss the half angle formula. So what we'll do, we'll start by first deriving a formula for sine of the angle A over 2. Now, to find out an expression for sine A over 2, we're going to use the cosine formula. So we know that if we have cosine of an angle A, so that's given by b squared plus c squared minus a squared divided by 2 times bc, where a, b and c are going to represent the sides opposite to the vertex A, vertex B and vertex C respectively. Okay, now we also have another formula for cosine of angle A, the half angle formula for cosine of angle A. We know that cosine of angle A, let's use this, A equals to, since we need a formula for sine A over 2, so what we'll use the formula 1 minus 2 times sine squared A over 2. So let's use this formula. That means we have 1 minus 2 times sine squared A over 2. This is going to be equals to b squared plus c squared minus a squared divided by 2 times bc. So let's rearrange the terms. We get 2 times sine squared A over 2. This is going to be equals to 1 minus b squared plus c squared minus a squared divided by 2 times bc. We're going to combine the two terms on the right hand side. That's going to give us 2 times bc minus b squared plus c squared minus a squared whole divided by 2 times bc. And on the left hand side, we have 2 times sine squared A over 2. Let's divide both sides with 2. So that gives us sine squared A over 2 on the left hand side. And this is going to be equals to, now what we'll do, on the denominator, we have to do 4 times BC. Now we'll try to rearrange the terms in the numerator. So here we have 2 times BC minus B squared. 2bc, let's write it down here, minus b squared minus c squared plus a squared. So what we'll do, we're going to consider a squared to be the first term. Then we will take negative as the common factor from the first 3 terms. So that's going to give us b squared plus c squared minus 2bc. Now, the advantage of writing in this particular fashion, that means now the second term in the numerator is going to become b minus c whole squared divided by 4 times bc. This is going to be sine squared A over 2. Fine. Now, a squared minus b minus c whole squared. So here we have the difference of squares. The difference of square means if we have x squared minus y squared, this can be factorized to get x minus y times x plus y. Let's use this. We will get a plus b minus c multiplied to a minus b plus c whole divided by 4 times bc. So this is going to be sine squared A over 2. Okay, now we have a formula for the semi-perimeter of a triangle. So we know that if S represents the semi-perimeter, the semi-perimeter of a given triangle ABC, that means S is going to be equivalent to A plus B plus C whole divided by 2. That means A plus B plus C here is the perimeter of the triangle. If we take the half of it, this is going to give us the semi-perimeter. Now, what we can do, we can use this to rewrite the factors in the numerator, a plus b minus c and a minus b plus c. Okay, let's do that. Now, we'll start with a plus b minus c. Now, a plus b minus c, we can also express it as a plus b plus c minus 2c. Means exactly the same thing. However, we can replace a plus b plus c with 2 times s. So we get 2 times s minus c. Then coming to the second factor, we a minus b plus c. Now this can be expressed as 2 times s minus b. Now we'll be replacing this in the place of the numerator. That's going to give us, so we have sine squared a over 2. So this is going to be equals to 2 times the product of s minus c times s minus b whole divided by, there's a 2 factor here as well, 4 times bc. So here we can factor out the 4 from the numerator and the denominator, which leaves us with sine squared a over 2. That's going to be equals to the product of s minus b and s minus c divided by bc. However, we need sine a over 2. So here we're going to take the square root. We're going to take the positive square root here. So sine a over 2, assuming a over 2 lies in the first quadrant. And that means we have the square root of s minus b times s minus c whole divided by bc. So this is going to be the half angle formula. That means sine of a over 2, that's given by the square root of the product of s minus b times s minus c over bc, where s is going to be the semi-perimeter of the triangle. Now that we have the formula for sine a over 2, similarly we can define the half angle formula for the remaining two sine functions. So we have sine of b over 2 and we need to express sine of c over 2. The best way to remember is, now if we have the angle A here, then we will consider the sides that are adjacent to angle A. So those are angle the side B and side C. Now for angle B, so we have the triangle here A, B, C. Now A, B and C are the sides opposite here, the vertex A, B and C. So here we are considering angle B. So we're considering the angle B here. So we'll consider the sides that are adjacent to angle B. So those are going to be the side A and side C. Then we're going to use s minus c multiplied to s minus a divided by c times a. And for side sine of c over 2, here we consider the vertex C, and the sides adjacent to vertex C is going to be A and B. So here we are going to get s minus a multiplied to s minus b divided by AB. So this is how we can express the half angle formula for sine. Now one more thing, why we took the positive square root. Let's talk about it for a moment. So we know that the sum of the angles of a triangle A plus B plus C, that's going to be 180 degrees. Now if the sum of the three angles of the triangle equals 180 degrees, that means if we pick up any one of the angle, that's always going to be less than 180 degrees. Now if A is less than 180 degrees, then if we take half of that angle, so that's going to be less than 90 degrees. Now any angle that's less than 90 degrees means it's going to be lie in the first quadrant, and in the first quadrant we know the sine function is always positive, and this is the reason why we considered the positive square root.